I want you to try something for me. It sounds simple, but it is actually going to break your brain a little bit. I want you to try and imagine a world completely without zero.
That is surprisingly hard to do. It is like trying to imagine a color you have never seen before.
Right. And I do not mean having $0 in your bank account. We have all been there, and that is a very real feeling.
Oh, absolutely.
I mean, a universe where the concept of nothing as a placeholder it simply is not allowed. No empty sets, no zero to anchor the number line, no off switch.
It feels almost claustrophobic, honestly. We are so used to zero being the absolute foundation of everything. It is the bedrock of our currency, our coding, our physics.
It is the binary off to the on.
Exactly.
But today we are taking a deep dive into a stack of documents that looks at zero and just says, get rid of it. We are looking at a massive project titled Fractal Tree of Primes. Living Tetrahedron of Numbers.
Authored by David Sioridze.
Yes, David Sioridze. And folks, let me tell you, this is not just a new way to do long division or something. It is a fundamental, ground-up reimagining of how numbers actually come into existence.
It really is. The sources we have are dense. We are looking at technical specifications, Python scripts, complex theorems, and what honestly looks like a screenplay for a math documentary.
Yeah, that movie concept is wild. We will definitely get to that.
It outlines a system the author calls Discrete Phase Arithmetic, or DPA for short.
And our mission for this deep dive is to decode this so-called hard arithmetic. We need to figure out why the system thinks prime numbers are actually structural defects, which is just such a cool phrase, by the way.
It is a great way to put it.
And we're going to unpack how it visualizes numbers as this living, breathing shape. So, buckle up. We are leaving the land of 0 and 1 totally behind.
To really understand where Sioridze is coming from, we have to strip everything back. Think about how we usually count. We use the decimal system, or computers use binary. It is positional. 0 is a placeholder. It tells you there's nothing in that specific column.
So the number 10 is just 1 10 and 0 ones. The 0 is just a seat filler.
Exactly. But Sioridze's system, which he calls a binary-ternary foundation, basically says no. A digit should not have a state where it is a sleeve or empty. The source material refers to this as the alive rule.
I got really stuck on this alive concept in the axiomatic basis. It says a digit is not a single symbol, like a 7 or a 4. It is actually a pair of indices.
Yes.
Specifically, pairs involving 2 and 3.
This is a crucial shift to wrap your head around. Think of it less like a number written on a page and more like a coordinate system or even like DNA-based pairs.
Okay, DNA. I like that.
In this system, the atom of a number is not 1. It is the relationship between 2 and 3. You have a coordinate like 2, 3 or 3, 2.
And the arithmetic value of that digit is the sum of those indices.
Sure.
And 2 plus 3 is what?
Nice.
Always 5.
Always 5. The base unit of this entire universe is 5. But here is the kicker, and this ties directly back to that alive rule. You cannot have 0, 0.
Because that would be dead.
Right. You cannot have 1, 1.
Yeah.
You cannot have 0, anything. Those are considered dead states, and they are strictly forbidden.
Why, though? What is the real beef with dead states here?
Well, Sioridze argues this from a perspective of information theory and thermodynamics.
Getting into physics?
A bit, yeah. In those fields, 0 often represents a state of maximum entropy, a total lack of information.
Total randomness or just a void?
Exactly. By banning the 0 state from the digit itself, he's trying to minimize entropy. He wants the number to be fully on, fully structurally sound all the time. Every single piece carries information.
Okay, but let me play devil's advocate here for a second. You have to represent nothing or space somewhere, right? You cannot just pretend the void does not exist.
Right.
Physics needs a vacuum. Math needs a 0 just to differentiate 1 from 10.
And that is where the omega element comes in. And honestly, this is where the philosophy of the project gets really interesting.
Yeah, the omega.
The documents describe omega not as a number within the actual system, but as a 0 fixer. It exists completely outside the ring of numbers.
Outside, like a referee just watching a game.
More like the canvas for a painting.
Oh, I see.
Imagine you are painting a picture. The paint is the numbers. That is the alive part, those mixtures of 2 and 3. The canvas is the omega.
It allows for the space to exist.
Exactly. It acknowledges that the void exists, but the void is not part of the paint. It is the container for it. It minimizes the entropy within the actual structure.
The source actually calls them omega zeros. It describes them as transparent points or clouds in the air. Visible, but totally intangible.
Precisely. It clearly distinguishes between the thing and the space where the thing is not. In our standard math, 0 is treated as a number just like a 1 or a 9. You manipulate it the same way.
Right, you add it, you multiply by it.
But in this system, 0 is the environment. It is the silence between the notes, not a note itself.
I actually really love that image. It makes the numbers feel much more intentional.
And because the digits are always alive, always this active mix of indices summing to 5, every number in the system has what the author calls a passport.
A passport, like an ID card.
Yes, because numbers are not just raw quantities here. They are histories. Think about it. In our normal math, if I hand you the number 10, you do not know if I did 5 plus 5 or 8 plus 2 or 1 plus 9 to get there.
Right, 10 is just 10. The history is totally lost.
The information is compressed. But in Sioridze's system, because numbers are built from these specific coordinate pairs, every single number retains the history of its origin.
So it remembers which specific indices formed it.
Exactly. It is a system of identity and memory, not just a value on a page. Every number carries its lineage.
So it is not just a bucket of sand, it is a family tree.
That is the perfect way to look at it, which naturally leads us to the engine of this whole thing.
Right, how does it actually do anything?
Exactly. How do we generate this family tree? The documents include a whole set of Python script that describe a process of iterative generation.
Yeah, I was looking through that code. It feels less like a calculator app and more like a simulation of bacteria growing, or maybe a crystal forming.
That is the fractal tree part of the title. The system operates like a biological growth algorithm. It has to start with a seed, or what the source calls a kernel.
The text lists a start basis. For example, it uses the first few prime numbers, 2, 3, 5, 7, 11, 13. That is our starting lineup.
Right. Now, in standard arithmetic, if you want to make new numbers, you usually just add 1. 1 plus 1 is 2. 2 plus 1 is 3. It is linear. It is predictable.
And frankly, for this system, it is boring. Boring is the enemy here.
We want alive. So this system works by summing triplets.
Triplets, yes.
The algorithm looks at the current basis, that starting lineup, and it finds every possible combination of 3 elements, A plus B plus C.
So it is taking 2, 3, and 5 and adding them up to get 10, then 2, 3, and 7 to get 12, and it just keeps churning out these sums.
Exactly. And here is the core rule of the engine. If the sum of a triplet is a number that does not exist in the structure yet, it gets born. It becomes a constructed node in the fractal tree.
Born really is the right word for it. It genuinely feels like the numbers are breeding.
That is exactly the metaphor Sioridze leans into. It is a living tetrahedron. And there are 2 theorems mentioned right there in the source that are super critical.
Theorem 1 and 2.
Yes. Theorem 1 states that any starting prime can serve as a seed for initialization. And Theorem 2 ensures uniqueness. Basically, no number is ever born twice.
So every constructed number has a totally unique set of parents.
Yes, a unique triplet that's summed up to create it. This is what gives this system that memory passport we just talked about. You can always trace any number back to its specific ancestors.
Okay, so we have numbers having babies via triplets. That explains how we get composite numbers like 10 or 12 or 15.
Yeah.
But what about the primes? Because this whole thing is called the Fractal Tree of Primes.
This is the aha moment.
Yeah.
This is where Sioridze completely flips the script on basically 2,000 years of mathematics.
I was reading Theorem 3 in the specs, and I had to read it twice because the phrasing sounded so strange. It defines a prime as a topological defect.
It sounds like a glitch in the matrix, does it not?
It totally does. We usually think of prime numbers as these noble, indivisible building blocks, like the pure atoms of math.
Right.
We find them using things like the sieve of Eratosthenes, which is basically crossing out everything that can be divided. It is a destructive process. We chip away the rock to find the diamond.
Exactly. Traditional math defines primes by what they are divisible by, or rather, by the fact that they are divisible by nothing but themselves in 1. It is a definition entirely based on division and subtraction.
But Sioridze's system flips that completely on its head. He defines a true prime as a node that cannot be built.
Correct. In this system, remember, the algorithm is constantly trying to build new numbers by adding triplets of existing numbers. It is like playing with Lego bricks. You combine 3 bricks to make a bigger structure.
Right, adding A plus B plus C.
But as it builds, there are holes. There are gaps in the structure. There are certain numbers that simply cannot be reached by summing 3 numbers from the previous generation.
No matter what combination you try.
No matter how you combine the 2s and 3s and 5s, you cannot make these specific numbers.
And those unreachable numbers are the primes.
Exactly. They are the failures of the construction process. They are, quite literally, defects in the topology of the math.
That is such a profound shift in perspective. A prime is not a special jewel. It is a hole in the brickwork.
But, and this is the absolute genius part of the system because the system cannot build them from the inside, it forces the system to expand.
How so?
The source says that because these nodes are unreachable via local sums, they must be added to the basis of the next generation.
Oh, so because the system could not construct the number 17, for example, using the triplets of the previous numbers, it grabs 17 and says, fine, you are part of the core team now, you are a new seed.
Precisely. The defects become the fuel. They expand the basis, which then allows entirely new triplets to be formed, which builds entirely new numbers.
So if there were no defects, the tree would just stop.
If every number could be built from the start, the tree would stop growing immediately. The primes are the structural necessities that actually drive the fractal growth forward.
That implies that without the glitch, the system dies. The perfection of the system entirely depends on its imperfections.
It's brilliant.
And there is a really specific experiment in the Python scripts provided in the source that just perfectly brings this to life, the 997 experiment.
Yes. This is a fascinating case study. It is almost like a dramatic story being told through code.
It really is. So the author sets up this experiment. Instead of starting with a nice, healthy group of small primes like 2, 3, and 5, he starts with a single large prime.
The number 997.
Right. 997. That is the entire start basis. Generation 0 is just the number 997 sitting completely alone in the dark.
Now think about the rules we just laid out. To grow, the system needs to form triplets. It needs 3 numbers to sum together.
But there is only one number. You cannot make a triplet out of one guy.
Exactly. So in generation 0, absolutely nothing can be constructed. The system is entirely stuck. It has a massive structural defect.
It is starving.
Yes, it is effectively starving. It cannot span the space of numbers at all.
So what happens when the script tries to move to generation 1?
Well, the script is programmed to scan for primes up to a maximum value, let us say 5,000, that cannot be built.
Okay.
Since nothing could be built, every single prime up to 5,000 is suddenly considered a defect.
Oh, wow. So the floodgates just open.
They burst wide open. The output in the source shows that generation 1 explodes from that single number, 997, to 668 new primes.
It just inhales them all.
It pulls in 2, 3, 5, 7, all the way up to 49,999 in a single generation.
That is wild. It went from total starvation to a massive feast in one step.
It is the system fighting for stability. Because the basis was too small to build anything, too small to cover the void, the system had to ingest a massive amount of defects to correct itself.
To stabilize the structure.
Right. It absorbed all those primes into the basis so that in generation 2, it could finally start building constructed numbers again.
It is like the system realized, I cannot do this alone, and recruited an entire army.
It beautifully illustrates the alive nature of this arithmetic. It reacts dynamically to its initial conditions.
So a balanced seed grows steadily, adding a few primes here and there. But an isolated seed triggers a total panic response.
A massive intake of resources to stabilize. It is surprisingly biological for a math theorem. It acts just like an immune system response.
And that biological visual feeling is clearly intentional. Sioridze does not just want us to read these numbers on a terminal screen, he wants us to see them. Which brings us to the movie concept in the documents.
Yes. The source material explicitly outlines a film or animation concept to visualize this living tetrahedron.
He describes the math as a documentary. He envisions a full 3D visualization where you can literally watch this process unfold over time.
It is very cinematic.
So set the scene for me.
Yeah.
If I'm wearing a VR headset inside this system, what exactly am I looking at?
Imagine a massive tetrahedron, a pyramid with a triangular base. It has 4 distinct vertices. The source describes these not as static points, but as flows.
Lots of numbers.
Right. V1 and V2 are the flows for the natural constructed numbers. V3 and V4 are the flows specifically for the primes.
Okay, and what about the edges connecting them?
The edges are the alive digits we talked about earlier, those 2 and 3 coordinate pairs. They are the actual connectors bridging the flows.
And then you have those omega zeros, the clouds we mentioned just floating around outside.
Yes, the transparency. The source describes the omega zeros as clouds in the air, visible but totally intangible. They define the space where the numbers are not. They frame the entire structure.
And the animation frames correspond directly to the generations we talked about.
Exactly.
Oh.
Frame 0 is the seed, just the initial basis. Frame 1 shows the branching out. You would see these connections dynamically drawing themselves between the triplets and their new sums.
And the source specifically suggests color-coding the nodes based on which generation they were born in. It mentions using a Vredes color map.
Which is a very specific choice.
Yeah, for those who are not huge data visualization nerds, Vredes is that really nice spectrum that goes from deep purple to teal, then green, and finally bright yellow.
So you would see this pulse of color expanding outward. Purple at the core, representing the ancestors.
And then moving to blue, green, and bright yellow as the fractal tree gets larger and more complex.
And importantly, you would literally see the defects. You would see the primes appearing as brand new anchor points.
You would see the structure trying to build itself, hitting a gap where a number should be but is not, and then suddenly that gap lights up and becomes a new pillar.
Exactly. It transforms the abstract notion of prime numbers into a tangible structural geometry.
Yeah.
You can physically see why they are necessary to hold the shape together.
It sounds genuinely beautiful, but does it just go on forever? Or does the movie eventually end?
That brings us to Theorem 4 in the specifications. Convergence.
Convergence. In math, that usually means things eventually settle down.
It does. The process is not infinite, at least not within a bounded space. The scripts have built-in constraints, like max value set to 1,000 or 5,000.
Right. You cannot compute out to infinity on a standard laptop.
But it is not just a hardware limit. It is a theoretical one. Because the set of true primes less than that maximum value is finite, eventually the system just runs out of defects to find.
It hits a wall.
It builds everything it can possibly build, it absorbs every prime it needs to absorb from that range, and then it stabilizes.
The source mentions the max generations parameter usually being set to something pretty small, like 5 or 10, so it stabilizes really quickly.
Very quickly. As we saw with the 997 experiment, it can do the bulk of the work in just 1 or 2 massive jumps. Once the basis is rich enough, once it has enough primes, it can construct almost any number via those triplets.
So the set of new, unbuildable numbers just becomes empty.
Exactly. The tree stops growing because it has completely filled its container, it reaches maturity, it has spanned the void.
Man. So let us step back and look at the big picture here. We have a system that outright bans 0 from the team.
Relying instead on a binary-ternary tag team of 2 and 3 that always sums to 5.
A system that minimizes entropy by keeping every single digit alive.
And it builds new numbers by summing triplets.
But the real magic, the thing that I think is really going to stick with me from this deep dive, is that it treats prime numbers not as the pristine winners of a division test, but as the losers of an addition test.
The unreachable nodes, the topological defects.
Which are then recruited to become the actual backbone of the next generation. It is a self-correcting, growing fractal structure. It feels so much less like cold, hard math and more like biological evolution.
It really challenges how we think about the very foundations of math. We usually assume our current axioms, like 0, 1, and linear succession, are the only way to do things.
Right, that they are absolute truths.
But this project, this fractal tree of primes, shows that if you change the axioms at the very bottom, you get a completely different, yet entirely internally consistent universe.
It is a universe where numbers have passports and a history.
And where nothing is just a transparent cloud watching from the outside.
There is a specific note from the author, David Sioridze, and buried in the source material that I think really sums up the passion behind this whole project.
I saw that note.
It is just a single line, but it hits hard. He writes, "This is my gift to humanity, 58 years of my life."
58 years. That is an entire lifetime.
That is a lifetime of staring at the number line and seeing something fundamentally different than everyone else.
It reminds us that mathematics is not just about discovery. It is also about invention. It is creation. He built a world where everything is alive, simply because he refused to accept that nothing should be part of the equation.
So here is the thought I want to leave you with today. We spend a lot of time in life trying to fit in, trying to be constructible, to be the logical sum of the parts around us.
We want to be the smooth result of A plus B plus C.
Exactly. But the really interesting stuff happens in the gaps.
It always does.
In Sioridze's living tetrahedron, the absolute most important elements are the ones that do not fit, the ones that cannot be built from what came before.
The defects.
The defects. They are the only reason the system actually grows. If you fit in perfectly, you do not expand the basis, you do not push the fractal outward.
That is a really profound way to look at it.
So if we stop viewing primes, and maybe even our own quirks as random occurrences, and start viewing them as topological defects required to hold the structure together, what else in nature works this way?
That is the big question.
Is the universe built on smooth division, or is it actually built on the structural gaps that force it to constantly expand? Something to think about the next time you cannot seem to make the numbers add up. Maybe you are just a topological defect waiting to start a whole new generation. Thanks for joining us on this deep dive.
Deep calculating.